Hello, welcome to task 3. So I've embedded this video into the Google form so that you can watch it and answer the questions below. All of the questions have to do with this video, so I hope that you're watching it because it will really help you. And I've put the slides on your weekly slides so that if you want to work through them at your own pace, that's totally fine and you can go back and look at them. So this week is about cladograms, and this is one of those things where sometimes it's really easy to get and sometimes it takes watching some videos or asking some clarifying questions. So please, please, please reach out to me if you are not getting it just from this one video. A clade is a group of organisms that have evolved from a common ancestor. So a clade is this ancestral organism and all of its evolutionary descendants. So everything that's really closely related will form up a clade. Usually they have common characteristics because of their shared evolutionary lineage. So think back to that pentadactyl limb or that hand that we looked at last week. All of those organisms have that very similar looking hand because they share a common evolutionary lineage. And cladistics is this method of classifying these organisms into clades. So from the Greek word klados, meaning branch. When we're looking at clades, you have to remember that it is, again, each clade is the ancestral organism and all of its evolutionary descendants. So we have this clade here because it shows our ancestral organism at the bottom, this little node, which we'll talk about, and all of its evolutionary descendants. Again, here, this will count as an ancestral organism, a node, and these are all of its evolutionary descendants. This is not a clade because even though it shows an ancestral organism, it doesn't encompass all of its evolutionary descendants. So it's showing two incomplete clades. And this one, again, has the ancestral organism, but not all of its descendants. This little guy is left out. So this is not a complete clade. Oh, you gonna change? So when we are analyzing cladograms, we analyze cladograms to sort of figure out what the evolutionary relationships are among organisms. So cladograms will usually have a few key features that you can always look for. There's usually a root, which is the initial ancestor. So the root, like a tree, is at the very, very bottom, and it's showing, just like when you have a family tree, it's showing the initial ancestor. And just like your family tree, you can't necessarily, if I were to draw my family tree, I would draw my parents and I would draw my grandparents and I would draw my great great grandparents and I would maybe get to my great 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 grandparents. And then my tree would end just because I don't have that knowledge, or even if I do have that knowledge, I don't have the space to show it. And so just like with a cladogram, our root isn't showing that it's the end of the cladogram. It's showing that that's the part of the cladogram we're looking at when we know, because we looked at that tree of life last week, that all organisms are related at some point, and so we're just showing one part of the cladogram. And then, as I spoke to before, nodes, which are these little parts where we get the branching off. So this is a node, and this is a node, and this is a node. Nodes correspond to a hypothetical common ancestor. So nodes are representing the common ancestor where we got two or more different species from it. So this node gave rise to this species, and then it gave rise to this species. This species eventually split into these guys. So nodes are showing us where those common ancestors are, or they're showing us where a speciation event occurred. And you guys know all about speciation because you've already been through task 2. Give me a second. I'm very sniffly. The outgroup is the most distantly related species in the cladogram. So the outgroup is usually what we use as a reference point to show us something that's different than the organisms that we're looking at. So the outgroup is usually, we don't have an outgroup up there, but it is a very distantly related species. And then we've already been over what clades are, a common ancestor and all of its descendants. So here we have our outgroup. It's very far away from everything. We have our root, which is the initial ancestor. We have our node, which is showing the common ancestor of A and B, and it's showing us that a speciation event occurred. So this used to be one organism, and eventually a speciation event occurred, and now we have a type of organism A and a type of organism B. So that is showing us all of these vocab words sort of applied. I would recommend that you pause the video and look at the words, look at the questions that have to do with root, node, clade, outgroup, before we go on. So cladograms are diagrams that show the most probable sequence of divergence in clades. This sounds really like a lot of big words. But it's just showing us what we think is what scientists think is the most likely evolutionary history of organisms on Earth. And so it's comparing DNA and fossils, and it's taking all of those different types of evidence that we already learned about and putting them in a visual form so that people can see what we think is the most likely evolutionary history. And remember that word divergence sounds a lot like divergent evolution, which is where something with a common ancestor, organisms with a common ancestor will develop new traits and become new species. So divergent evolution is how we get new species. So each of our branch points, each of those nodes represents a speciation event by which distinct species are formed. So that is a speciation event where we get new types of species. So think back to task 2 and those ways that we get speciation. So those different types of isolation. And the fewer the number of nodes, this is a fill in the blank on your questions, the fewer the number of nodes between groups, the more closely related they are expected to be. So the fewer the number of nodes between groups, the more closely related they are expected to be. I'm trying to move my camera so that you guys can read that, but it's not happening. So the fewer the number of nodes between groups, the more closely related they are expected to be. And let's take a peek at that. So here, if we're looking at this cladogram, and we're looking between all of these species, we have species 1, species 2, and species 3. It's showing us that 1 and 2 are more closely related. And don't be fooled, they're not just closely related because they're next to each other, but it's because they have a more recent speciation event. So this is the only node that's separating them, versus between 2 and 3, they're separated by this node and this node. On this cladogram, 1 and 3 are the most closely related. And on this cladogram, which you can't see because of my camera, 3 and 2 are the most closely related. So the fewer the nodes, if there are fewer nodes in between species, the more closely related they are. Cladograms can be read to deduce evolutionary relationships between humans and other primates. So there are lots of cladograms out there that show us how closely humans are related to other primates. So according to a cladogram outlining the evolutionary history of humans and other primates, humans, chimpanzees, gorillas, orangutans, and gibbons all belong to a common clade, which is the hominoids. So we're going to look at this guy right here, which is showing us the relationships between humans and all of these different primates. So on this cladogram, humans and chimpanzees are the most closely related because they are separated only at this node. That shows us that that is the speciation occurrence. This is the common ancestor between chimpanzees and humans. Here is where humans and chimpanzees share a common ancestor with gorillas. So at this point in history, we had a common ancestor that split into gorillas and another type of species that eventually gave rise to chimpanzees and humans. So when you are looking at these relationships, you want to find if I were to ask you who's the most closely related, you want to find who has the fewest nodes separating them. So humans and chimpanzees only have this node separating them, versus humans and gorillas are really close, or chimpanzees and gorillas are next to each other on this chart, but they're separated by this node and this node. So it's showing us that chimpanzees are more closely related to humans than they are to gorillas. And what I would recommend, if it asks you how many, I ask you in the form, how many millions of years ago organisms share a common ancestor, then you're going to want to go to this side. And MYA stands for millions of years ago. So chimpanzees and humans, you're going to follow this line over. And it really helps me if I have a piece of paper that I hold up to my screen to sort of be able to follow that line really clearly. And you're going to tell me how many millions of years ago chimpanzees and humans shared a common ancestor. So if we follow this line over all the way, it's in between 5 and 10 million years ago. So probably something like 7.5 million years ago, chimpanzees and humans shared a common ancestor. And you can do that for any of the organisms on here. So if I asked you how many millions of years ago humans and old world monkeys shared a common ancestor, you would go at this branching point, because this speciation event, this shows us the most recent common ancestor of old world monkeys and of humans. And then we have, if I asked you, but that is also the same as when old world monkeys and gibbons shared a common ancestor. So if we trace gibbons back to where it meets old world monkeys, we have it right here. So that would be the same. It would be about 25 million years ago. So that's how we can measure how long ago how long ago species shared a common ancestor. And this just shows you that cladograms can be positioned either way. So they can be vertical, like this, showing us more of what a tree looks like with our roots and then our branches, or they can be positioned horizontally. And you'll see this shows the same information. Humans and chimps are really closely related, and then gorillas, orangutans, gibbons, humans and chimps, gorillas, orangutans, gibbons. But this one is positioned the other way, and it's showing us our ancestral primates are at the root, and then the number of millions of years ago that organisms split. So remember I asked you humans and chimps how many millions of years ago they shared a common ancestor. It looks again like it's about 7. So this is just reiterating the information from the other cladogram, but it's the same information, it's just turned on its side. I hope that makes sense so far. So then we're looking, there are a lot of questions. I'm going to work through these 4 questions with you, and they are the same 4 questions as the ones in your guide. So helpful hint. Humans are most closely related to which organism in this cladogram? So we want to find humans, and they are here on our cladogram. They share they are most closely related to the organism that they share the most recent node with. And so humans and kangaroos are attached right here, which means that they split this many millions of years ago. So much more recently than humans and, say, turtles, which shared an ancestor here, or humans and sharks, which shared an ancestor all the way back here in time. So imagine that this is like our modern day, and this, as we travel down this line, goes longer and longer ago. So imagine this as being millions and millions of years ago, and this is current day. What is more closely related to the turtle, the kangaroo, or the shark? So here's our turtle. We want to figure out who it's more closely related to. Is it more closely related to a kangaroo or more closely related to a shark? I'm going to give you a second to think about it. It is more closely related to a kangaroo, because if we go and trace this line, we see that turtles and kangaroos shared a common ancestor here, and turtles and sharks shared a common ancestor all the way down here. The closest evolutionary relative of the shark that is shown is the tuna, because they share a common ancestor here. Frogs and sharks. Frogs are more distantly related to sharks. They're branching away from sharks all the way up here. And then the common ancestor of all 7 organisms is shown all the way at the bottom. That's our root, is the common ancestor of all 7 of these organisms that are shown. That's the root. It's all the way down here. So you would describe it, because we can't really draw anything that easily, as being the very bottom. So even lower than shark is where we are seeing a common ancestor of all 7 of the species that are shown. Oop, oop. And then this, if this wasn't confusing for you, the way that scientists organize cladograms is by looking at the characteristics that organisms share. And so this one doesn't show us what the characteristics might be, but we can kind of think. Humans and kangaroos are both mammals, which means they both have hair. Nothing else on here has hair. And so we can kind of imagine that hair would be marked here, and everything after this has hair. What's different between turtles and everything else on this list? Well, turtles have a shell, and so maybe right here we would mark shell, showing us that from everything on this point onward, there would be a shell. So that's what's being shown here, is that our most basic characteristic, every organism on this cladogram has this characteristic. They all have vertebrae. So think about vertebrae as being the little bits of your spine. All of these organisms have vertebrae, but sharks don't have a bony skeleton. So everything on this point onward will have a bony skeleton, but the organisms behind this do not have a bony skeleton. So sharks are before we get this bony skeleton mark, and so sharks do not have a bony skeleton, but everything from this point onward does, which means ray-finned fish have a bony skeleton, amphibians have a bony skeleton, primates have a bony skeleton. Think about us, we have our bony skeleton, we're primates. Rodents and rabbits have a bony skeleton, crocodiles, bony skeleton, birds, bony skeleton. Everything from this point onward on the cladogram has 4 limbs. And you can see this visually. Ray-finned fish do not have 4 limbs. Sharks do not have four limbs, because they're before that mark on the cladogram. Everything after this has 4 limbs. Even the birds, think about wings being limbs. Amniotic eggs are the eggs that you think of as being sort of egg-shaped like chicken eggs, but they're the eggs that we also have. They are developed in amniotic fluid. They contain amniotic fluid. And so amniotic eggs, everything after this point has an amniotic egg. And this is where we get this weird splitting. So primates, rodents, crocodiles, birds all have amniotic eggs, but we have a separate split up here to show it's primates and rodents, and they all have hair. So we're only going to mark hair on this little branch of our tree. Primates and rodents and rabbits all have hair. We can also think there's no characteristics marked, but we can think about what the characteristic might be that separates out primates or rodents and rabbits. Primates have opposable thumbs, so that's like our thumbs that we use for video gaming and grabbing tools and all of the things that we do with our hands. So primates, if you put a little mark here, it could say opposable thumbs, something like that. And then eggs with shells, crocodiles and birds both have eggs with shells. Birds only have flight. So maybe there would be a characteristic up here that would say flight. And so if I asked you, what traits do birds and crocodiles have in common? Well, they both have eggs with shells, but they also both have amniotic eggs. They both have 4 limbs. They both have bony skeletons, and they both have vertebrae. They have all of these traits that are leading up to birds and crocodiles. Versus if I asked you what traits sharks and ray-finned fish have in common, well, let's go back. Ray-finned fish have a bony skeleton, but sharks do not. They both have vertebrae. And so that's the only thing that ray-finned fish and sharks have in common. If I asked you what characteristic do primates and ray-finned fish have in common, well, primates have all of this stuff. They have hair, amniotic eggs, 4 limbs, bony skeletons, vertebrae, but ray-finned fish only have bony skeleton and vertebrae. So in common, they both have these 2 things, vertebrae and bony skeleton. I am going to end this video here. If you have questions still, I've included another video for you to watch, which is just another person doing this on YouTube that maybe will help you make more sense of it. It's just a longer explanation that might be very helpful if you aren't understanding this just yet. And remember, I'm available via email, via Google Classroom, Google Meets. So please reach out to me if you're still struggling or have questions on any of this stuff. So the questions below on the Google form all have to do with this video. Some of the answers I gave you in the video, some of them I didn't, and you actually have to use your brain a little bit more. But you got this. I hope you have a great rest of your day and good luck on task 3.